So PCBs are a legacy pollutant. We banned them in the 70s, but we started making them during World War II. They are very resistant to degradation, which means they stick around areas like sediment, so at the bottom of a river or lake or anywhere where there's water, but there's also dirt. I'm currently deploying passive samplers in a river near Seattle. It's called the Lower Duwamish River, and it's part of a 3-year campaign to figure out the extent of contamination of PCBs. Now there's a lot of creatures that live in the sediment. They all interact with the dirt throughout their entire lives, and because of that, the contaminant, the PCB, concentrates in the animal. That enters at the bottom of the food chain, and eventually, of course, it comes to us. So if you live on the river and you fish in the river, you're going to be eating fish that have toxic levels of PCBs in their tissue. This fall, I'm going back to the Duwamish River to deploy some of my modified samplers, and we're going to try to figure out the input of PCBs due to stormwater. After 3 years, we want a better understanding of the sources of PCBs to the river. Fieldwork is far and away my favorite thing here. I've been like waist deep in mud, I've dove for clams, I've been on a whole bunch of boat trips, and I'm really looking forward to going into a stormwater outfall. In this building, you have people working on both the science and the engineering. So you get a really diverse group of people, from biologists to chemists to fluid mechanicians, working on understanding the problem, and then you have the same type of people working on coming up with a solution. With CE, I just got a very excellent broad view of what people are working on and what is considered a useful problem to tackle.